So there's been a lot of hype around hardware powering the AI revolution that we're all witnessing right now. But today I want to walk through what may be actually happening underneath the surface in terms of why there's nearly half of data center projects are either being canceled altogether or kind of delayed. Because there is the thing. Deploying modern AI hardware is not as simple as just buying more chips. It's just more than that. The systems need huge physical footprint, rows and rows of server stacks, racks. We're talking constant power, cooling network, and all the infrastructure that make those machines usable in the real world. So, talking about the spending, right? And the spending that we're talking about in this build out is pretty massive. For instance, in 2025 alone, the world's biggest tech company estimated to have allocated around $400 billion in capital, right? Expenditure for AI infrastructure alone. To put that in perspective, right? Adjust for inflation, that is roughly the cost of funding two Apollo programs in a single year. Or said another way, it's like building 9 Manhattan projects side by side. So we're talking huge sum of money here. And of course, the biggest winner from all this huge spending is no other than NVIDIA. Its CEO, Jensen Huang, said that the company was on track to ship around 10 gigawatts of GPU in a single year. Now that sounds pretty impressive, but there's a problem with that number, right? Because the estimate that we have in terms of market estimates suggest that the total operational capacity of all the AI data center currently running in the whole world today is around 7.7 gigawatts. So that creates a very obvious question. If NVIDIA is shipping 10 gigawatts of GPU capacity, but the world has only 7.7 gigawatts of operational data center capacity, where exactly are those chips supposed to go? That gap suggests that the financial investment may be moving much faster actually than the physical infrastructure needed to actually use the AI. Of course, in this case, the regular, the usual standard response from the industry will be that, those chips are kind of like not missing. They're not missing. They're just meant for data centers that are still being built. But that's fair enough. So to test that idea, you have to look at the pipeline in terms of data centers that are actually in the pipeline. Tech companies have announced plans to bring about 21 gigawatts of new capacity online by 2027. But when you compare those announcements to real construction data that is actually available on the ground, that number drops sharply. Instead of 21.5 gigawatts, we are looking at just about 6.3 gigawatts in terms of what is actually under construction. And so we now have a number that needs, and in fact, if you put that in context, that's 6.5, you have to put it in context, because in industrial real estate, under construction can mean a lot of things, all right? Sometimes it means a mostly complete facility, but in other times it may actually mean that, just concrete foundation poured onto some ground and no actual infrastructure ready to hold live server. So when the project is technically on the way, that does not mean much in terms of anywhere being close to being ready for AI, hardware, right? And so there's this other issue that people often overlook. You see, not all data center electricity goes to the GPUs. There's a whole lot of other things. You're talking about a huge chunk of this power is consumed by cooling systems, networking equipment and other overhead. And so depending on the design, roughly 46 to 65% of this power facility can actually be going to support systems, which means only part of the electricity that we're talking about here actually is available for computing. And now, so even if every existing facility upgraded today, and even if every built site somehow came online immediately, the physical space and power needed to plug in 10 gigawatts of new GPUs still may not exist. And that has big implications because it suggests that billions of dollars of hardware may be sitting in limbo, produced, purchased, and booked financially, but not actually deployed, right? So to understand where these chips are going, we have to start at the source, okay? And that is the Taiwan Semiconductor Manufacturing Company, otherwise known as TSMC. Right, much of this hardware ultimately begins right there. What we may be seeing is a classic, situation in modern in supply chain problem known as bullwhip effect. In plain English, that simply just means that the fear of scarcity distorts buying behavior. In other words, because supply from TSMC is kind of tight, large tech companies do not want to lose this space in line. And so what happens is when chips becomes available, they buy immediately, even if their data centers are nowhere near ready to actually accommodate that. And the result is something pretty unusual, okay? We're talking in a situation where you can end up with sales of crates of advanced hardware sitting in warehouses, not because the buyer wants to use them right away, but because they are afraid they might not be able to get them later when they actually need it. So instead of chips flowing straight into production, we have a situation where some of them maybe, getting stockpiled and just stays, hiding somewhere. And when you look back at NVIDIA, the company's own supply chain tells an interesting story, okay? Like over the course of a single year, for instance, right, NVIDIA internally inventory report quadrupled, okay? Now that points to a major backlog in the system, right? Because it suggests the company may be dealing with upstream constraint and future commitment by holding more materials and product inside the pipeline. In other words, the financial purchase cycle, right, may have become disconnected from the physical reality of infrastructure deployment. Okay, so eventually, though, those chips will go somewhere, right? But they have to be installed on large campuses, the connected to the grid, powered, cooled, and kept running. And this is where the biggest physical bottleneck may be showing up actually. The main constraint is no longer just chips performance, it's now power, right? You see, connecting data center to electrical grid requires highly specialized equipment, especially large high voltage transformer that step down industrial power loads, right? And the problem is manufacturer cannot produce those transformers fast enough. Obviously, these are huge equipment. So lead time over the past several years have stretched dramatically. Prices now, kind of like more than double. On top of that, tariffs and trade restrictions affecting manufacturing hubs, in places like China and Mexico have made procurement even more difficult. When companies have money, land, hardware, they still may be stocking, on the basic equipment needed to turn their site on, essentially. And this is not theoretical, right? In Santa Clara, there are reports of fully fitted data centers sitting offline, simply waiting for local utilities to provide power. That's how serious this grid constraint has actually become. Some companies have tried to work around this by simply trying to power their site with some sort of natural gas, but that creates another problem. Natural gas is not exactly that cheap. I mean, the prices have risen so sharply, and so now the workaround itself becomes expensive enough to damage profitability, okay? And once that happens, the economics of the entire project starts to break down in a way that is not really nice. And running an industrial turbine may buy time, okay, but it is not in itself a sustainable long-term business model, obviously. So what we're really looking at is this. Tech firms have raised an enormous amount of money, right? A not a huge capital. But that capital is running headfirst into the hard physical limits of energy, infrastructure, and all that. And once that starts happening, accounting becomes very important. So one of the biggest criticisms from investors like Michael Burry has been the way AI hardware is depreciated on corporate balance sheet. A lot of companies still spread the cost of AI GPUs over 6 years, when in reality, the useful technological edge of these chips may fade much faster, sometimes in as little as 14 months. And that matters a lot, okay? Because if a chip becomes economically outdated long before it is fully depreciated, then profit can look much healthier on paper than they really are in the real sense. And when you combine that with supply hoarding and grid delays, the problem pretty get worse. You can end up in a situation where high-end chips sitting in crates physically untouched, but already losing relevance because technology cycle moving too fast. Okay, facility finally opens up. It still faces another big challenge, which is the cost of energy, right? Because the situation is such that older chips are less efficient, right? Especially when it comes to power. So that means that they require more power to produce the same output as newer systems, okay? And so if electricity prices are rising at the same time, hardware is aging, the operating economics gets squeezed on both sides. And that leads to very, very brutal outcome, okay? Because at the end of the day, multi-million-dollar racks of cutting-edge hardware can begin to behave more like a future e-waste, right, than productive asset eventually, meaning simply because they cannot get online fast enough to generate the return that is required of them. So then the obvious question would now be, how exactly are these companies able to post profit? Profitability in the current AI rollout depends on accounting assumptions, just plain simple. That's something the appearance of how fast these assets are actually losing their value. And the story gets even bigger. A large part of this infrastructure build out is being supported by private credit markets, firms like Blue Owl and BlackRock. So the flow looks something like this, okay? You have a private credit helps finance data center. That's financing, of course, force massive GPU orders. Those GPU orders drives NVIDIA's revenue. But the loan behind those projects still depend on one thing, right? One simple, important thing, that the data center eventually have to become profitable, okay? And if they do not, because the power is too expensive, construction is delayed, or all kinds of other problems, like all the hardware becomes outdated, like in it of itself too quickly, then the old loop start to reverse. At that point, the threat doesn't stay inside tech. It can travel backward into the credit markets that funded the build out in the first place. NVIDIA sit in a very exposed position inside this loop, because if the end user data center fails to make money, panic buying stops. And if panic buying stops, NVIDIA future revenue pipeline becomes much more vulnerable. But the larger risk goes beyond NVIDIA. If unprofitable fixed infrastructure has been financed on optimistic consumption, the fallout could spread into the broader financial system supporting it ultimately, right? So in the essence, we're talking about a situation where what we may be seeing is a technology industry that has substituted massive capital spending for proven profitability. The core mismatch is simple. Money is moving in one speed, right? But the grid expansion, construction, and energy costs, they move at another speed. And until the life cycle of modern AI hardware is aligned, with the actual pace of power generation, data center deployment, this 400 billion AI structure build out may remain highly, very, very unstable proposition. Because when capital outruns the grid, the whole system literally just goes dark. So what do you think? Is this AI infrastructure bubble or just a messy phase in a much bigger transformation? Let us know in the comments. And if you found this video useful, Make sure to subscribe, like, and hit notification bell so you don't miss the next one. Thanks for watching, and I'll see you in the next one.